Now, you got the idea about how to find out the shear flow in different direction. Now, based on these things, what are the things you need to find out? You need to find out resultant, overall resultant shear flow. This overall resultant shear flow generally you can find out by Qx resultant component square plus Qy resultant component square plus Qz resultant component square, whatever the things I have shown. So, if a structure is subjected to all types of different types of loading, then to find how to find out the resultant shear flow, that idea you got. This resultant shear flow you should keep it in mind, should be the maximum, this should be the maximum shear flow of that welded joints, this you should keep it in mind. Okay. So, you should choose those location where you are getting this shear flow in different direction which are maximum in nature. This resultant shear flow you need to, now this resultant shear flow you got, this you need to compare with allowable shear flow. This allowable shear flow idea is very well known to you. The allowable shear flow generally you need to find out based on the electrode material property, I have already told you. So, from there generally you can easily find out what is allowable shear flow. I have already discussed this thing in details, and find out this ratio. If this ratio is less than equal to 1, then you are in safe side. If it is greater than 1, then what happens? You need to redesign, you need to relook into this. Either you need to increase the throat thickness, or you need to change the dimension of a structure. So, okay, these are the procedure generally we need to follow for design a what is called welded joint subjected to different types of combining load. So, here just little bit I am explaining the procedure. Okay. So, here first of all you need to find out Q allowable stress, first stress, Q allowable stress. This Q allowable stress generally you can find out from the electrode composition. I have already discussed these things, how to find out this thing. So, this Q allowable, then after that you need to find out what? Qx resultant component, Qy resultant component, then Qz resultant component. Okay. How to find out these things I have already explained in previous slide itself. Then third point is you need to find out resultant shear flow by the equation Qx, this equation already, this equation I have written here. Okay. So, I am not writing here again. Always you should keep it in mind, this QR should be the maximum resultant shear flow of that weld. Whatever the number of welds will be there for that structure, once say that total number of welds resultant shear flow should be the maximum shear flow. So, you should choose that location where you will get maximum, you can say resultant shear flow, this should be maximum one. After that, this you need to compare with allowable shear stress. How? That is QR by Q allowable should be always less than equal to 1 for safe design. This you should keep it in mind. Now, we will solve one problem, then it will be very clear to you. Okay. So, let us consider this is a problem which is a welded joint in a plain frame. So, the problem statement is like here I am just reading this problem statement. A 3 cross 5 cross 0.25 RST, we can say rectangular steel tank, you can say, or a structure, rectangular structure you can say. Okay. These are all in inch, unit is inch, is connected to a support by placing a 0.1875 or 3 by 16 inch flat weld. This you should keep it in mind. This is given as, it is generally what it is called, this size of the weld is given as this, okay, 3 by 16 inch flat weld on each side. The structural analysis of the plane frame containing this member indicates the member is subjected to force as shown in figure below. So, this is the rectangular RST you can say, which is subjected to what? Px force, that is 4.9 on KIPS, that means kilo pound. This is actually kilo pounds, KIPS means kilo pounds. It is subjected to a Py force, that is 3.54, and it is subjected to a bending moment. You should keep it in mind. This is generally bending moment. This bending moment, how it is? So, according to, you see, according to the thumb rule, if you just do, then you will get how it is coming. You can say this bending moment direction is like this. Okay. Here bending moment is mz, which is 28.7, and its unit is kilo pounds inch. Okay. That means force into distance. Moment is equal to what? Moment is equal to force into distance. That is why its unit will be force unit kilo pound into distance. Okay. This you should keep it in mind. So, this thing is given. Now, here what are the things we need to determine? Determine whether this weld is adequate for E70 rod. E70 rod you know. So, E70 is what? 70 is FU. So, what are the things here it is given? FU is 70. So, here I am directly just writing these things. What are the data given? Here data given is, you can say length is 3 inch, breadth is instead of length or breadth, whatever it is, you can say let's this you write as B is 3, then here I am writing H is 5 inch, okay. Then its thickness of this is given as 0.25. So, thickness means thickness of this wall plate, this you should keep it in mind. Now, you see, and it has a Px value equal to 4.91 KIPS, Py is given as 3.54 kilo pounds, okay, and also given mz is equal to 28.7. Okay. So, here what we need to find out? We need to check whether this weld, if we made with the help of E70 rod. So, here E70 electrode is given. So, E70 electrode means here Fu is equal to 70. This you should keep it in mind, 70 kilo pound per square inch. You should keep it in per kilo pound per square inch. Okay. KPS you can write. So, I have already discussed in details actually how to find out so far how to find out Q allowable. So, I am going to start this solving this problem to check whether our main intention is to find out first Q resultant maximum, you can say this you need to find out. We need to find out Q allowable also. These two things we need to find out. What is these two things? After that we need to find out the ratio of these two and check whether it is less than 1 or greater than 1. So, here first things we need to do, total length of the weld LW you can easily find out here total length of the weld is 2 breadth 2b plus 2h you can write. So, 2 into breadth means 3 plus h means 5. So, you can say 16 inch, this is the total weld. Now, here another things we need to find out, that is actually what, that is generally IZ you can say. So, this is, let us consider z axis, okay, and let us consider this is our height and this is our breadth. Okay. So, height direction is y direction. So, you see this is our y axis, this you can say. So, now what are the things we need to find out? I am writing here, this is y axis. Okay. Here I need to find out what is, because to find out the shear flow due to this bending moment mz, what are the things required? We need to require ZW. What is ZW? ZW I have already explained in details, that is generally IZZ divided by T into, always you should keep it in mind, H by 2, H by 2, with this you should keep it in mind. Okay. This already I have discussed in details. Actually this H by 2 actually y, because this furthest distance you need to take here from, in this case generally you need to consider this furthest distance is y is equal to here H by 2, this you should keep it in mind. Maximum distance you should take, perpendicular distance generally we need to consider here. So, here I will just show you how to find out this IZZ component. So, you know these things very well. In next slide I am just going to show you in details about this. So, here you see IZZ component is very important. For different section you can find out IZZ. So, this is y, this is z axis. Okay. Now, for let this weld, its throat thickness, always you should keep it, this is generally throat thickness, here also this is generally throat thickness, this side also this is throat thickness T, and this is also throat thickness T. Now, for a weld about a axis, let us consider this is a weld, this is a weld whose throat thickness is T. Now, what happens about ZZ, you need to find out the what it is called, what is the IZZ of this weld. So, from here to here let us consider the distance is, let us consider H by 2. Okay. Now, how to find out the what is called IZZ for this one weld. So, for this one weld, first of all we need to find out, let us consider about its own axis, let us consider Z1 Z1. So, I Z1 Z1, you know this will be, let us consider this is your breadth is B. Okay. We know these things 1 by 12, I am not going to discuss how this 1 by 12, IZZ will be B, you can say thickness of the weld BTQ. This is about its own axis. Okay. Now, what is about this parallel axis IZZ? This IZZ will be generally about its own CG, whatever the moment of inertia generally Z1 Z1 you are getting, that moment of inertia or second moment of area you can say, plus that area into distance square, distance square h by 2 square, perpendicular distance square, this you should keep it in mind, perpendicular distance between centroidal axis and parallel axis. This is actually based on parallel axis theorem, parallel axis theorem, this you should keep it in mind. 1 by 12 BTQ plus area is what, V into T into h by 2 square, correct, this you can write. Now, here as this T is very small compared to B or H small, that is why what happens, this TQ term also will be very small, TQ term you can consider neglect, you can neglect this TQ term, higher order term. So, these are the terms you can neglect, what I am telling, understand, these are the terms you can neglect here. So, here what are the things you can say, you will get Vt into h by 2 square, this you should keep it in mind. So, this is for one weld. So, similar two welds are there. So, here these two welds are there, this is if it is parallel to z axis, then we are getting this IZZ for one weld, here I am writing is like this. Okay. Now, let this is z axis and here one weld is there. Okay, here one weld is there whose height is h and thickness is t, and this is our centroidal axis of the all weld. Always you should keep it in mind, this ZZ axis is the centroidal CG axis of all welds, this you should keep it in mind. So, for this weld, this left side or right side weld, what should be the IZZ? So, IZZ here will be directly you can say 1 by 12 T HQ, T HQ. Okay, this is one weld, this is you can say second weld which is perpendicular to the direction of ZZ, correct. So, what is the overall IZZ will be you can say 2 into IZZ1, because which are similar and which are symmetric also, plus 2 into IZZ2, this you can write, correct. So, this will be equal to you can write as 2 into BT into h by 2 square plus 2 into IZZ means 1 by 12 T HQ, correct. These are the things is very clear to you. Now, this is the overall what? This is the overall IZZ. Now, this ZW, what does it means? ZW I have already told you, ZW equal to you know, ZW is equal to IZZ divided by throat thickness into what? Throat thickness into Y, Y means here h by 2, always you should keep it in mind. So, if you just do these things, what are the things you will get? ZW, this ZW calculation I am just showing 2. So, here I am writing BT h by 2 square, 2 is there divided by T into h by 2 plus 2 into, that means 1 by 6 I am writing, 1 divided by 6 T H Q divided by T into maximum parallel distance is h by 2, that means y is here h by 2. Okay. So, what are the things we are getting? So, here T T cancel out, here T T cancel out. Okay. So, we are getting here, here you can say 1 h by 2 cancel out. Okay. So, 2 into b into h divided by 2 plus you can write here 1 by 3 h square. Okay. So, here generally this 2 also cancel out. What are the things here you can write? This will be equal to your b into h plus 1 by 3 h square. So, you got the idea what is ZW. So, ZW you got as for this configuration of weld, you got ZW is equal to BH plus 1 by 3 H square. This you should keep it in. For different types of configuration of this weld system, let us say these 4 welds, 4 side welds are there. If there will be only let us 2 side weld, then what should be this ZW you can easily find out. Then let these 2 welds are there. If there will be just top side weld and bottom side weld, generally you have used for what it is called this tank connection, then there this ZW will be different. If this tank is instead of rectangular, if it is circular, then for circular what should be the IZZ, you know this thing very well, that IZZ equal to pi t RQ. I have already shown these things. So, based on this thing generally you can find out for different configuration, you can find out what is the IZZ for different configuration of weld joint, and based on this you need to find out what is ZW. So, here as it is a rectangular shape and it has 4 side it is welded, that is why at throat area section, what should be its ZW, that I am showing. So, this ZW will be B is given as 3, H is given as 5 plus 1 by 3 into generally H is given as 5 square. Okay. This will gives you a value equal to, you can say directly I am putting 23.3 inches square. Now, what are the other things required? Now, we need to find out what is due to this what is Qx resultant. First of all, I will find out Qx resultant will be due to force Px by Lw plus Mx divided by Zw. Always you should keep it in mind. Okay. And here this resultant will be Px is how much it is given, directly I am putting this thing, Px is given as 4.91 and Lw is 16 is given, and here sorry here Mx not, it is not Mx, it is Mz actually. So, here Px generally Qx resultant will be Px by Lw plus Mz by Zw. Okay. So, here Mz is given as how much? Mz is given as 28, this is given data, and Zw already I have calculated 23.3 inches square. Okay. This will give us a value of 1.54 kilo pounds per inch. This you should keep it in mind. This is Qx resultant. Now, what is Qy resultant? You see Qy, there is only one force, there is no torsional types of force is there. So, and this bending, this bending moment also, this bending moment Mz will not create any stress along the direction of y, that you can find out. Along the direction of y, there will not be any bending stress. So, that is why here Qy resultant will be Py by total length of weld. So, here Py given as 3.54 divided by 16. So, this will be given as 0.221 KIPS per inch. This you should keep it in mind. So, shear flow in x and y direction we find out. Here shear flow due to along z direction, this will be equal to 0, because there is no z component of force, as well as due to bending moment there will not be any bending moment along what, along z axis, there will not come any bending stress in what it is called shear plane or weld plane. This you should keep it in mind. That is why here QZ resultant will be 0. What should be now our overall resultant shear flow? This will be, we can easily find out, that is actually Qx resultant square plus Qy resultant square plus Qz resultant square, correct. So, this will give us a value which is equal to, directly I am just putting these things, 1.55 KIPS per inch. You know these things, its unit is generally force per unit length. Okay. So, this you got. Now, we need to find out what is Q allowable. So, Q allowable, generally I have already told you how to find out Q allowable. So, Q allowable generally we can find out with the help of, we know this what it is called, 0.707 into Fu into W divided by N, factor of safety. So, here generally 0.707 into, here everything is given, you can say Fu is given as 70 into W is given, size of the weld is given as in my previous slide itself I have shown. Point, this is size of the weld, means always you should keep it in mind. Fillet weld, this is size of the weld, means it is actually leg length. Okay, always you should keep it, this is actually W. So, this W is given as 0.1875, this divided by, factor of safety is given as 2.8, it is already provided. This will give you a value, Q allowable is 3.31 KIPS per inch. This you should keep it in mind. Now, we need to check the ratio of this QR divided by Q allowable. This we will check. Thus, QR is 1.55. Let this is equation number 1, this is equation number 2. So, based on equation number 1, we get 1.55 and Q allowable is 3.31. So, this will give us a value which is equal to, you can write as 0.47, which is much lesser than 1. So, whatever the weld you will do with the help of E70 electrode and with a factor of safety 2.8, it is very well satisfied and it is very well safe side, you can say, for design, because it is much lesser than 1 value. That means, this welding is safe. Now, it is very safe, that you can say. So, what you can do? You can reduce your weld size, instead of, because they are the weld leg length we consider as 3/16 inch. So, what you can do? This 3/16 inch weld give us a very high safety, because 0.47, because you can go up to 1, what I am telling, understand. So, what we can do? This weld will consume more weld material, more power, more cost, what I am telling, more time, you can say. So, what you can do, instead of using this weld, you can relook by considering W is equal to 1/8 inch and check whether this value is less than 1 or this ratio is less than 1 or not. If it is less than 1, then you can reduce this weld size also, what I am telling, understand. So, this way generally you need to check, you need to design your weld connection. Okay? This you should keep it in mind. Now, I am going to show another problem that is a very important problem. This is a that is a plane frame problem, this is a plane grid problem. So, here I will just discuss about just different steps used to find out what it is called this resultant QR, that I will show you how to find out the resultant QR. And also I will find out what is the ratio between this Q allowable by QR, and we will check whether it will be in safe side or not. That means, QR by Q allowable we will check and whether it is safe side or not. These are the references which I followed for making this content, you can say. So, these are the references which I followed for this lecture. Thank you.